All right, guys, so the first thing we could hit on table maintenance. This machine always does what it's told, but if it can't drive to where it's going because there's shit in the bearings, basically you want to keep your bearings clean. This is an older style bearing that we use. It's still actually a really good bearing. It's called an SGR 35, I believe is what it was. This on the gantry is the new style bearing that we're running on every axis, but this is still a really good bearing. With this bearing itself, you want to keep this guy clean. You want to get all the debris out of it. Just take some like 30 weight oil, wipe it down. You don't want to use like detergent style oil because detergent oils will break down seals. You know, it's meant to penetrate, like a WD-40 or a penetrating oil is meant to get inside things. We're looking for lube. We're not looking to break down rust, right? So you don't want to use a detergent style like PB Blast or WD-40. You just want 30 weight oil. So you want to keep this guy clean. You want to keep this guy lightly oiled to stop it from surface rusting. This guy, used table, really good shape, originally from Chazon Smoke, right? They've done a pretty good job greasing their bearings. You want to keep all of that off there, you know, like just clean it regularly. The biggest death of this table is definitely cleanliness and maintenance. If you keep this guy clean, lightly oiled, and also you can grease these. We've started recommending using 30 weight oil. So just drive it to the end and then wipe it down in oil. And the reason being is that the grease zerks on this guy, they're not like an excavator. They're not like a pin on an excavator. So you can take your Milwaukee grease gun, plug it in there and just hammer it until the grease starts spitting out. You do that with those bearings that are sealed, it blows the end caps off of them. So we've been having a lot of problems trying to convey that message to people. So then we've got away from telling people, hey, put some grease in it, because if you're by yourself as an operator, you need to plug your grease gun in, give it a quarter pump, drive it, let it recirculate, give it another quarter pump, and it gets to be kind of a to-do or an operation. So what we've started telling people is wipe it down with glass cleaner. You don't want to wipe it down with brake cleaner. Why not brake cleaner? Because it'll degrade the seals in your bearings. It's hard on things. It's meant to break down and it can ruin plastic and seals and make it brittle and all that. Glass cleaner seems to work really well, or some light duty cleaner. Clean it all off, wipe it down in some oil. The oil will recirculate in the bearings, get in there, you're good to go, and it stops grease from getting all over your machine. There's nothing wrong with grease. Problem is that people grease them improperly and they end up exploding the end caps off. Same thing with your gear rack. You want to keep this gear rack lightly lubricated. Some guys will run dry graphite on it. That doesn't really seem to extend the life at all. Mainly what extends the life is not over tensioning the motors. So if you take your motor and you just ram it into that gear rack, you're going to cause premature wear on your pinion. Your pinion always wears out faster than the gear rack itself because it's traveling around at a bazillion revolutions, vice versa. So that's what really is going to kill your pinion itself. As far as maintenance goes with a rack and pinion system, if you walk up to it and you shake it, see, I can feel this movement right here. If I take this and I shake it, right? That is basically proving to me that there is, the rack and pinion itself is going clunk, 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 clunk. We need to take that backlash up. So essentially what we would do is lift the gearbox into the mesh, and we want to lift it up incrementally. So basically the gear is moving like this. We want to bring it up so that way it doesn't move. If you continue to shove it up and you just go ham on it, you're basically going to over tension it and cause premature wear, and then your pinion won't last as long. Also, if you have bad bearings, what happens? Premature wear, because that pinion is just fighting the ever-living Jesus out of itself to force itself through bad bearings. What causes bad bearings? Lack of cleanliness, lack of maintenance, right? So this guy, a little bit out of whack. This guy on the X, not bad. We can check that other Y motor. That guy's got a little bit as well. So we need to pop the covers off and then retension the motors, and then that'll give you guys a much better hole quality. Hole quality, the whole idea is this machine will drive itself around in a perfect circle, but if the pinion is struggling to travel back and forth because it has backlash, you're gonna end up cutting ovals. You could cut a perfect circle on this axis because it's decently tight, but then on your Y-axis, you're gonna cut basically an oblong hole going this way because your gears are out of whack. Let's just drive this ahead to a nominal point where we can work on it. We want to drive that axis ahead so that way we can get out of the way of the cable track and then retension that. So we'll do that real quick and we'll get right back. So we're going to need 3/8, 3/8 socket right away, 3/16 Allen, because your motors aren't powered up until I turn the controller on. they still have some residual resistance. So you can't check motor tension until the motors are on and locked up, because when the motors are on the controller, they're locked up and they're super rigid. If you do it with the motors off, you could turn the pinion and kind of go, oh, I still have some backlash, but really you're just taking and just slamming the gear up in there. And then by the time you slam it up in there, you go, yeah, that seems good and tight. Problem is you just over tensioned the hell out of it and it's gonna cause premature wear. So we're gonna run it down, leave the motors on. Nobody touch the controller because you don't want to lose your fingertips. So, you know, by somebody driving it while we're messing with the gear, and we'll get this guy retension. So to drive this machine, we hold Control Shift, and then I drive it ahead. I'm going to drive it down so that I'm out of the way on that side. On this side, there's a cable track. I want to get it out of the way of that, so then that'll allow us easy access on the non-working side, access the gear. This is what I would consider our working side because it doesn't have the cable track side on it. So this table is placed correctly in here for easy loading and unloading. You don't want to work over top your cable track, just because if you guys are in here loading with a forklift, you're going to end up contacting that cable track, you know, vice versa. This is the easiest side to access, so this table is set up here in a good position. Let's go ahead and pull these guys off. Thank you. Might want to hold on to that if you're doing it yourself. I'm going to come in here, and I can still feel it moving back and forth. Then I'm going to take these nuts behind here and I'm going to loosen them up a little bit. This guy works great to move this up, but then we need a wrench to get this guy. Yeah, ratchet, 6-point ratchet wrench, or yeah, this works pretty decent. So I'm going to loosen these up so that way it's still holding everything decently tight. And then all I'm going to do is I'm going to crank these tension bolts upwards ever so gently. And that will then move the gearbox up and reset the mesh into the gear. And then I keep shaking it, and I'm just doing like very baby micro turns up and until I get the backlash to go away. It's almost out. And these are rigid mounted gearboxes, and the reason why they're rigid mounted is that if we took and we had the gearbox pivoting on a spring or a gas cylinder or something like that, it's super easy for the motor to become, what it does is it drives one way and it wants to drive itself into the gear rack and bind itself up. It drives the opposite way, it wants to work the pivot out of itself. So this is a maintenance thing that needs to be done ever so often, and it doesn't take long to do. I mean, hell, I'm almost done and I've got 5 minutes into it. And then we're pretty solid right there. And then I take and I lock down my bolts, and we are good to go. And our newer tables have different gear rack and different bearings, but same avail. It's still kind of the same system, but you can see how it's not clunking back and forth. And you can tell if you over tighten it, when you drive it around, if it sounds terrible. No big deal. Still decently smooth, not like, right? So we'll put the cover back on and we're good to go. So your water, how you fill that and what the story is with that is you've got Boss Quench. That is a solution that stops rust, fungus, and bacteria. You want to replace that yearly. I don't know when the last time they probably replaced this is. I would probably and recommend just draining it and replacing it. I did see some crud floating around in it. Do not run borax. Do not run any sort of weird internet form stuff. I don't care what people say online. The stuff we have works. It works pretty good. You can see that this table isn't rusting and it's probably 5 years old. Don't mess around with anything on the internet. Just run the stuff that we do. If you buy a new table and you don't use it, voids warranty, because I don't want the thing looking like a used Honda and then you're gonna try and warranty it out after a year. So you wanna replace it every 6 months, but if you wanna really kind of like pinch your pennies, you do it every year. The solution itself does not actually evaporate out of the table. What it does is every time you pull a part off, you lose it when you either take your part and grind it off, shake it off, and it's wet. So the water itself traps about 90% of the smoke, the soot, all the jazz that is created when plasma cutting, which works great for the northern states because it's cold up here and you don't want to take all your warm air and blow it outside and then you just paid for hot air and you're trying to heat the world and melt all the snow. It'll never turn this into Florida, no matter how hard you try. Or you can put a big dust collection system on it, which is fine for like a downdraft. They're just kind of wildly expensive. So a guy that's looking to get into this more economical, water's definitely a better option, potentially. Some guys don't like water because they don't want to deal with it. In general, it's the most popular model we have. Water also helps cool down the plate itself while you're cutting, preventing warping and twisting, because no matter what, it doesn't matter what cutting process you're using, whether you're machining, cutting with a laser, cutting with the plasma, you're going to introduce heat into it unless you're water jet cutting. The material will unlock stress and move. So with water, it helps control the total amount of heat, controlling the warpage itself. So water is twofold. It captures the dust, collects all the sediment, and then stops your part from warping. With water, when you'll have a little bit more slag potentially than downdraft, but if you're cutting properly, you won't really have a ton of slag anyways. So if we go to slag and or how to interact with that, the faster you go, the less slag you're gonna have. The faster you go, probably the more improper cuts you're gonna have, because as you're traveling faster, your arc, your plasma, is traveling and lagging behind, and it's also cutting with a bigger diameter. So the faster you go, the less slag you're gonna have, but not as clear, concise, or dimensionally accurate of a part. Also with holes itself, we slow down on the holes to allow the air to blow the plasma arc straighter to get better hole quality out of a plasma table. Plasma tables, the Achilles heel is always holes. Does it do it? It does it just fine. You can cut still a 1/4 inch hole in 3/16 or 1/4 inch. We just actually oversize it a little bit and the bolt falls right through it every time, but it's still plasma. It's not a laser. Works just fine. You just gotta kind of learn how to interact with the cutting process itself. Keep your water treated, and you're gonna have good success out of this and it won't rust. Again, we really recommend Boss Quench. We can ship it direct to you. It's a lot cheaper if you guys come to the factory and pick it up, just because it's expensive to ship things in a 5-gallon bucket, because it already comes pre-mixed in a solution in a 5-gallon bucket. We don't recommend, and I've spoke with the guys that help make that for us, you can never get it mixed up correctly if it's sold in a powder form. So it's always sold in a liquid form, pre-mixed, so that way it ensures proper dilution. It's all mixed up nicely in the water itself. What's the proper height to have your water level? I would say in general, most people are running it about 1 inch below your slats. And as far as proper water height, we've got 7 inches of water storage, 5 inches of cutting area. You want to open your valve, which drains your water. So if you come over here and I hit this valve right here, I can then hear the air start rushing out. That will then lower the water level. I need this valve open, and I'm gonna take a garden hose, I'm gonna put water into the table, and with this valve open, and I'm gonna fill this 7 inches up, that is then full. If I had air plugged in here, I would then turn this valve open, and air would then rush into the bottom tank, displace the water, and raise it to whatever height I wanna be. So you do not want to open this valve and allow air to go in the bottom tank and just walk away, because it'll overfill and it'll cause you problems. I dumped about 50, 60 gallons on the floor one time. One time I did it, never again. Don't walk away from it. So this is your water drain, and this is your water fill. This is the air pressure that controls your pneumatic scribe. To operate your scribe, you'd have to plug this guy in, turn this valve on. What that does with that air pressure holds the pneumatic scribe in the up position. This machine being used and a lot of use being done on it, I don't think Jason Miranda really uses scribe all that much. So there's plenty of gunk that's holding this thing up. But proper maintenance would be to keep this guy clean as well. Again, hitting on maintenance things. This guy right here, this is your breakaway switch. This switch will not operate if this is dirty. So all this debris will build up with metal dust, and it will then push the mount away, and it will dislodge the torch, causing a breakaway situation to be present. The torch is self-centering. So this guy, you can adjust how tight your torch is by loosening these nuts and forcing the set screw in, which would then self-center it on these pins. But we want to make sure that this is clean, debris-free, and then we want to set that so that way your torch is good and tight, so that way it self-centers itself. And again, this is your breakaway switch right here. It operates with this little plunger. What this guy is a homing switch. So this guy, when you lift up, you can hear it click. When you hear it click, what that is another micro switch telling it where the height of the material is. What that allows us to do is not run ohmic sensing, so we can cut on top of painted material. You don't want to cut on this. This is your water. This is a shield for your water tank. But if you had rusty material that's painted, you could then cut on top of it yet because our ohmic sensing will not sense the material. This right here, this wire, is your ohmic sensing wire. You need a special consumable from Hypotherm to operate that. The wire plugs into on the backside, and all this is an ohm meter touching together, setting the height of the material. This sets the height of your material, and so does the ohmic. The ohmic can cause problems when there's water on the material because it'll touch off the water. Water is conductive, so then it will touch off the water and then set an improper height, try and strike an arc, but it'll be too high above the material and not transfer the arc properly and not pierce properly as well. If that happens, it'll throw an error and say arc not detected, and the water is then blown away because it takes air to strike an arc. You can then just hit run and it'll touch off again. But generally, guys that are plate cutting, doing 3/16, 1/8 inch, quarter, half, 3/4, you don't really need to run ohmic. You can just tuck this guy up and get it out of the way, no big deal, and we'll just use the plate. So why would we run ohmic? Is if you're running a light gauge sheet metal and your sheet metal is bowed up a little bit, it'll allow us to touch off the material without the weight of the torch pushing down. So the weight of the torch on this would push the material down, and then it would find home, and the material would then follow the torch up, and then it'd be like dry firing a pistol point blank into the material, causing premature consumable wear. That's the reason why we'd run ohmic, is on lighter sheet metal, 18 gauge. Our older tables, it was called Feather Touch with Command CNC. It's called ohmic touch on all of our other models. So super, super simple. And also a big thing that everybody gets wrong is that this wire is not your digital torch height. Your digital torch height is collected out of the plasma unit and then brought into the controller, and we then manipulate the data from there, controlling the height. This has nothing to do with digital torch height. This wire has nothing to do with digital torch height. It is all collected out of the plasma unit. So you do not need this wire to run digital torch height at all. It is not digital torch height. I promise you, it is not, right? So this, all it is to find home, basically like you're running an ohm meter, touching the two leads together, no big deal.